Hello there and welcome to A2 Maths on June 2018, paper 1. Here we're looking at question 13, an integration question. So show that the integral from 2 to 0 of 2x times the root of x plus 2 dx is equal to this expression here. So we have this x plus 2 inside an awkward square root and we need to somehow deal with this. So what I'm going to do is I'm going to set x plus 2 as equal to u. So I'm going to do an integration by substitution in this question. I also have x in this integral as well, so what I can do is I can always take the 2 onto the other side, and now I'm going to be replacing x with u minus 2, and I'm going to be replacing x plus 2 with u inside this square root. I also need to sort out these limits. Now when x is equal to 2, u is going to equal 2 plus 2, that's 4. And when x is equal to 0, u is going to equal 2. So now my new limits are from 2 to 4, and it's going to be of 2 times x, now x is just u minus 2, and times the square root of x plus 2, but I'm going to substitute in u, so it's going to become u to the power of a half. I also need to now sort out this dx at the end. Now if I take my substitution again, and I differentiate it, so I get dx, so du by dx. If I differentiate x with respect to x, I get 1, so du is equal to dx when I multiply onto the other side, so I can replace du with dx straight away, so it's going to be du. Okay, so now all that's left for me to do is just to expand these brackets, so it's going to become, I'll move the 2 to the front, u to the power of 3 over 2 minus 2u to the power of a half du, and now it's just a bit of first year integration, so it's from, let's do the integration now, so it's going to be 2 multiplied by, now we increase the power by 1, divide by the new power, so it's 2/5 u to the 5 over 2 minus, and then it's going to be u to the 3 over 2, and then divide by the new power, so it's going to be 4 over 3, between the boundaries of 4 and 2. Okay, so let's now start plugging these in. It's going to be 2/5, and substituting 4 in first, that's going to be 4 to the power of 5 over 2, minus 4/3, 4 to the power of 3 over 2. And now I need to do the subtract part, so it subtracts now 2 substituted in, so that's going to be 2/5, 2 to the power of 5 over 2, minus 4/3, 2 to the power of 3 over 2. Okay, let's just see how I'm getting on with compared to my answer. I've got 15 as my denominator, I've got 5 and 3 on my denominators at the moment, so I think I'm along the right track. Let's now sort out what I've got inside the bracket here. So I've got 2 times by, now 4 to the power of 5 over 2 is 32. Let's just do this on the calculator just to be sure. So 32 times by 2 is 64, so it'd be 64 over 5. Minus, and then 4 to the power of 3 over 2 is going to be 8, so that's 8 times 4, which is 32, so it'll be 32 over 3. Then it's going to be minus 2 to the power of 5 over 2, well that's going to be 4 root 2, so that's going to be 8 root 2 over 5, and then the double negative from expanding this bracket here and here is going to give me plus, it would be 2 root 2, so that's going to be 8 root 2 over 3. So let's now grab our calculator and simplify what we can here. We've got 64 over 5 minus 32 over 3. And that gives us 32 over 15. And then for the last part here, it's going to be plus 8 root 2 over 5 plus, so it'd be 8 root 2 over 5, but that's a minus on that one, and then plus 8 root 2 over 3. That's going to give us 16 root 2 over 15. Let's just make sure it ends up exactly how they want us to write our answer here. So if we now expand the brackets, we get 64 over 15 plus 32 over 15 root 2. So therefore, if I now pull out 32 over 15, I get 2 plus root 2. Brilliant, lovely. It's ended up just as I wanted it to. Perfect. So that's 7 marks for that question there, an integration by substitution question for question 13. Let's now move on to question 14.